artificial intelligence. Some say it will save the world. Others say it will take all our jobs. There is a truth in between. Let's speak about it. AI without the PhD, because somebody has to translate this stuff.
Hey, and welcome back everyone. AI without the PhD, because somebody has to translate this stuff. And today I want to talk a bit about the history of AI, because there is a big misconception. People think there are two eras of AI. One era before OpenAI and ChatGPT, and one era after that. But to be honest, this is not true. AI is not a new thing, and while I do my PhD research for my PhD papers, I found papers that go back till the 1960s. So, to be fair, it's not new, and thinking that OpenAI is the first time people thought of intelligence machine, that's maybe a bit of a disrespect for 70 years of computer science. So before OpenAI came out with their models, and Anthropic and Cursor and Cohere, Mistral, you name them. Yeah, I don't want to put anyone in the spotlight. They all do great work, and the last years we had a big boost in that technology. But, well, to be fair, the first computer that beat a human in chess was in 1997. So that was the first time a machine defeated a world chess champion. And you see, 1997, it's a long time ago. It's almost 30 years now. And we had this kind of learning machines back that time. Also, banks are detecting suspicious transactions with machine learning for decades. And they had a big interest in doing that, because if a fraudulent transaction went through, the money is gone. If you can't stop it, you lose the money, and recovering it's horrible, complicated, and expensive. So best is being faster than the execution and stop it before it's executed. Also, Google ranked search results for ages, or we have Netflix and Amazon recommending things to you, and all this happened before OpenAI was a topic. So you see, there is a broader history. And if we think that further, if we come to the point that we speak about spam filters, so spam is an issue since email was invented. I'm tending to say the first commercial use case of email was spam. But we have those spam filters, and they are around for ages as well, even longer than the chess champion was defeated. And they made sure that the email of the Nigerian prince who wanted to send you $40 million never reached you if you had a proper spam filter. And you were able to train those filters. You were able to tell them this is spam and this is expected email. So they were learning. And that is a kind of learning system as well. So you see, we go way more back in history than OpenAI. So if AI has been around for decades, what actually changed? And I think here's the point where we have to speak about that. To understand that, we need to go back in time when computer filled rooms. Memory was measured in kilobyte and not in gigabyte. And researchers were already wondering whether the machine could think. And this is a way back. So we are in the 1950s and 1960s. And maybe Alan Turing is a name that rings a bell for you. And Alan Turing came around with mentioned in his 1950s paper the question, can machines think? So the 1950s is where it started somehow. And I don't want to explain here the Turing test deeply, but it's important to point out that there are people seriously thinking and discussing that stuff way more time before usually households even owned a television. So it was a long time before a computer was in every house. It was a long time before the mobile was invented. And it was even a long time before television were common. So you see where far that went down. And in 1956, the Dartmouth workshop was the first time artificial intelligence was formed as a term. So the term artificial intelligence goes down to the 1956. So there is a lot of stuff happens since then. People thought about rules and how reasoning can work. They thought about reality checks, so how to figure out if you talk to a machine or if you talk to a human, which is part of the Turing test. And if you want to really go down that rabbit hole, I recommend Googling that and read a bit more about Alan Turing and his testing methods. So there is a lot of stuff. And the way up to here, it's a long way. You see, it's decades. Computers became first good in puzzling. And then they start with mathematical proofs. Then they went into gaming, and now they are into planning problems and solving them. So this is where it now arrives into reality. And I think this is part of the story why OpenAI and ChatGPT as the front runner, and now Anthropic with Claude and again Cursor, Mistral, Cohere, they become more and more popular because now the use cases reach the point where a usual household can work with it. And I see it more and more that people don't Google things. They just went to ChatGPT and ask things. And Google now started to replace the search with some kind of AI bot that is answering, that is in the upper part of the search results, where you can go into a conversation about the first finding. I think this is interesting that Google, who made a fortune on ranking and classifying and categorizing websites, is not going that way as well. And I think that tells us a lot of stuff. So when we speak about that, AI is now way beyond the traditional use cases we had in the past, where we classified images and asked, is this object a cat? Or the ML use cases where companies ask if my machine is failing somewhere soon. And then we came the 1970s and the 1980s, where they start to solve or build expert systems. So expert systems were more a thing where the idea was you find an expert, you interview them, and then you extract the knowledge out of those interviews and put them into databases. And then you apply rules to that knowledge to make it to make it accessible for different angles. We spoke about that in the session about vector databases. They came way later, but this is something that's now solved with vector databases. So the idea was to go there, for example, in the medical field, saying if a symptom A and a symptom B and a blood test C are given, so is the conclusion that we can consider a disease D. And that kind of expert system were built in the planned or thought of in the 1970s and 1980s. And from my own experience, I can say medical systems are horrible, complicated, because we have a lot of different options, variables going in. And in the worst case, a bad decision leads to a death of a human. And that makes me a bit careful playing around with medical stuff there. But nevertheless, they started that way, and companies loved this approach because it sounded very practical to them. And being practical is usually a good measurement for success. You can have the greatest system at all, but if there's no practical use case for the industry, it's not working. So this is where we come from, and so as the businesses start to discover this kind of research and this kinds of tests and these kinds of initiatives, they went down that way, and it went more into into a business use case where they said, okay, if I have this machine and I have these measurements of sensors in the machines, so please, what's the outcome? Is my machine healthy or not? So this is a 50-50 thing. It's sometimes it's more like a rules engine that's trained. Sometimes it's really machine learning. So it depends the angle you do. And even still nowadays, I see a lot of machine learning use cases where I think a rules engine would do it perfectly fine without the overhead, but people go down the ML. So there is a kind of gray area between ML and rules engines. So the AI now, it's going down the way, and well, AI repeatedly suffered from enormous expectations, and this is something we see also nowadays. And so researchers promise that computers can realistically deliver results. That leads into increased fundings for the research, for sure, because everyone wants to have this and want to be the first, so best is secure the researchers to get the access. Then expectation increased, and well, sometimes reality is not aligned with expectations. And there were a lot of promises made, and we still see that today. So if I scroll through LinkedIn, I see a lot of AI coaches making promises that are not delivering in the reality at all. But they need to exaggerate their promises because they want to sell something. And at the end, researchers need funding, so they do the very same, but in a more scientific way. But at the end, people try to gain attraction by the market, by the people with the money. They try to secure funding. They try to drive revenue, and therefore they need to sell the stakes high. So it's a bit, yeah. And back the time, there was a lot of promises made and was not delivered. So we had something called the AI winter. And that was a long time between the 1980s, 1990s, till the day OpenAI had the breakthrough, and they positioned their product. They came out with a very strong marketing. They came out with a very compelling message, and they came out with a very mature product that hit the market at the right time. So we were somewhere in the post-COVID time where technology was really in ask, and there was a real rally. And that time, OpenAI came out with a first model and had the breakthrough. And this ended then the AI winter. So there was a long time nothing really happening. So researchers were working on it. We had ML, which is on purpose models, but the Gen AI made the throughput in that scenario. And well, that was a good timing for them, to be honest. And they hit the spot of the market amazingly well. But this is now where AI comes to a place that it is, on the one hand, useful for every household. It's affordable for the households. If you see an OpenAI subscription is around $30. If you have a subscription in Anthropic Claude, it's $30. I'm not saying that they are priced to the cost. There is a lot of a lot of marketing price in there to make it affordable, to gain market shares. So there are different researches about the real cost of token, and whatever you take, it should be way higher. So it's an interesting part where it will go. But at the end, well, they ended the AI winter. They came out with something, and they came out with something that's way more useful than the machines, than the models we had in the past. So if the message contains urgent transfer, put it that way. If it contains lottery winning, put it in the spam, and whatever. So those models are now working way more sophisticated. And why are they doing that? So what we have there are neural networks. And this is a very old idea that finally gets enough horsepower with the increased increased power of CPUs, of memory. Memory is now way more affordable than back the time. The CPUs are way more powerful. And what we now got is something called GPUs, graphical processing units. And in a difference to the normal, usual CPUs, the GPUs are way better suited for neural networks. And that gives the industry the power to implement long-sitting papers, long-sitting concepts, and fuel them with the horsepower needed to do amazing things. That also led to the situation that you again can't afford a memory, and the graphic cards are horribly expensive because now the gamers are competing with the AI companies about the resources. So that's a second thing. But meanwhile, this stuff is powered by those stuff. And keeping in mind, this is a perception we had already in the 1950s. So we thought about it, but we were not able to build it because we didn't have the horsepower to run it. And that came now everything to one point. And in 2012, there was the first big milestone with AlexNet and ImageNet. So the first time we saw rapid advance in image recognition, in speech recognition, in translation, and in computer vision. So that was the time we got those fancy dictate function software where you can just speak and then you upload the MP3 or you upload the WAF file and got the text translated and written into a Word. Way before we had the smartphones just talking in and get this fancy text out. But that was in 2012 where we had the big breakthrough in that. And again, there is a business use case for that. You can get rid of the secretaries. So if you have a CEO, a CFO, a COO, or whatever, a head of something, back at the time they were talking on tapes and they gave the tapes to the secretary for typing, and now they can speak into a digital device. It's stored, they uploaded it, and they get it down. The first couple of years it was horrible. I tried it myself. I remember on Dragon Dictate and stuff like that. It was horrible. You had to train, you had to read sampled sentences so it can adapt your speech, your voice, your pronunciation. But then after you did the training, it got better and better and better. And nowadays it's just working without the training. So we got deep learning then later. So also a thing where we can do a full-blown session about. So systems where you were able to use for image recognition. But again, I don't want to drag completely into neutrons, weights, and back propagating here now. Maybe this is another story, and maybe this is something for the podcast AI with the PhD, because there is a lot of knowledge behind that. But I don't want to touch this now. I just want to mention the word. So if you want to go deeper down the road and the rabbit hole, you can read it. But then in 2017, the researchers introduced transformer architecture. And in the paper, Attention is All You Need, they wrote it down. So in 2017, we got this, what is now behind GPT, because GPT is general purpose transformers. Again, I don't want to explain the mathematics behind it, but they are amazing. Let's speak a bit about what it helps to address. So if you say, I went to the bank, was that a financial institution or did you go to the park and sit on the bank? Well, you see, you have different angles to the word, and the word is not a one-by-one mapping to meaning. And you need the surrounding words for that. So, and this is where transformers became extremely good in modeling relationship between pieces of language. And this is what is behind all those LLMs, is this transformer stuff. So researchers discovered something very useful. If you train very large models with enormous quantity of data, of text, they begin to learn the statistic structure of language. And this is what behind of all the LLMs. So whenever you ask OpenAI, ChatGPT, Anthropic, Claude, you ask something, you get a statistical answer. So the model is calculating a statistical answer, and you get the most likely answer to your text. And this is why they're hallucinating. This is why they are sometimes not accurate. And this is why they are working the way they are working. So these are transformers. So what did ChatGPT now actually change? And this is the payoff. They didn't suddenly introduce AI to the world, as I mentioned. So they allowed people to directly interact with AI. And that was the first time people were able to use this and to chat with a machine. And before that, AI was living behind some interfaces like recommendation engines, fraud models, and whatever. So you were already interacting with them when you transferred money on the bank, when you used your credit card, when you were online shopping. You interacted already with machine learning, with artificial intelligence, but you didn't notice it because it was abstracted behind a website, behind a credit card tab, or whatever. So now it's the first time that you are able to go to a website and say, hey, I want to solve this problem in Python. Hey, give me a recipe for a nice banana bread. And you get a direct response from the machine. You can go, I'm currently, maybe see it behind me, I'm currently in Melbourne. So I can go to ChatGPT and say, hey, I have an afternoon in Melbourne. I'm interested in old or in history. So what should I do? And it sends me to Cook's cottage over there and gives me the history of Cook's travel around the world and how he made the maps of the world and how he contributed into fighting Skorbut and stuff like that. This is the first time I can interact with the machine and get a direct response that is affecting my life, and I recognize it. And that's the big breakthrough OpenAI brought us. So let me sum it up as we hit the 20 minutes. So OpenAI didn't invented AI. They didn't invented machine learning, but they made it accessible without hiding it behind a facade, behind a API or whatever, to people. And they did it at a very good timing after COVID, when tech was on their top, and they did it in a way where people were able to implement it into their lives. And this is a great example of how to place an amazing product, but they didn't invented it. So everything goes back to the research of Alan Turing and what happened between the 1950s, 1956, where the word artificial intelligence was first time written down, and today. So there's a lot of research in between. There's a lot of scientists in between that work. There's a lot of technical improvement in with the CPUs, the memories, the GPUs, that led us from Alan Turing's research in the 1950s about artificial intelligence through all the way neural networks, transformers, up to OpenAI, Anthropic, and you name them. So I hope I was able to give you a brief view into the history of AI, and see you next time.